So we did, this is like the previously on part of a television show. I don't know how I'm going to end up cutting this down, but maybe I can get the previously on Lost.
Previously on Lost.
Because I'm sly. You know how we be? Maybe you don't. Please tell me I'm actually recording everything. Yes, okay. And of course, that's 7 minutes in. The summary is going to be its own Math Minute video. Oh, hey, we're doing a Math Minute. Guaranteed to be no more than 10 minutes long, obviously. Guaranteed to be on whatever day it is that I end up uploading this. We've kind of ended up in a series where we began by looking at the distributive property, just what it was, how it worked, how we could utilize it to evaluate expressions in a variety of ways, especially algebraic expressions that have variables, in which case we're not evaluating, but we're simplifying something. But then we really started to look at, well, what does this enable for us? And we looked at the area model for multiplication, which was a way to represent double distribution. So again, just to get this up here, let's do 34 times 12. We know that our standard algorithm would say, let's start by multiplying the 2 and the 4, and then the 2 and the 3, and so, of course, 2 times 4 is 8, 2 times 3 is 6, and then we do a placeholder. We know now that essentially what we're doing is we're taking that 12 and we're splitting it up into a 10 and a 2. And so when we perform our distribution, we get 34 times 10 plus 34 times 2, or 340 plus 68. So again, coming back over here to our standard algorithm, as we multiply the 1 by the 4 and the 1 by the 3, that's where we're getting the 340. Again, hopefully you can see that connection. 340 there, 340 there, 68 there, 68 there. And you can also see how the distributive property answers this question for us, or I guess I should say partially answers this question for us, why we end up doing addition in service of multiplication. And so we get our 8, we get what happens to be 10, carry the 1, and so there it is, 408. And of course then what we wanted to do was push that further and say, why don't we do double distribution? Why don't we take the 34 and also split that into 30 and 4? The 12 again will be 10 and 2. And so we can see these various products, 300 plus 40 plus 60 plus 8. And as we add all that together, again, we're going to get a total product of 408. So several different ways to represent this. Utilizing the distributive property helps us think through what's going on here. We then took the distributive property and we said, okay, let's apply that to something like an 11 trick, right? Let's start generating some mathematical heuristics with all this stuff. So 34 times 11, we learned, oh, you can take your ones digit and immediately write it down. You can take the sum of your ones and your tens. 3 plus 4 is 7, and write that down. And then finally, you can take your tens digit, and presuming there are no carries, write that down, and we get 374. We used it for one of my absolute favorite tricks. We took numbers that were just slightly above 100. So let's say something like 103 times 106. We think of literally as 100 plus 3 and 100 plus 6. And we get products like 10,000, 300, 600, and 3 times 6 is 18. And as we line those up, we can see something interesting happening. These two digits, we just end up bringing down the product, which was 18. These two digits, we just end up bringing down the sum, which 3 plus 6 is 9. And then, of course, we know we want our answers to be slightly above 100 times 100 is 10,000. And so that's what ends up happening here. And we get 10,918. So to finish up the series, I want to do two things. One I'll do in this video, one I'll do in the next video. The first thing I want to show you is one more of these distribution tricks. There are lots of others, and maybe we'll get to those later on. But this one I'm going to show you how to multiply numbers slightly less than 100, rather than numbers that are slightly greater than 100. So let's look at one last trick that double distribution enables. Again, there are lots of others, but this is the last one we will look at for a while. Let's say I did something like 96 and 92. Presumably, you don't think there's a great way to end up multiplying this in your head. Of course, we could just write this down and do our standard algorithm, but even that is not going to be super fun because I'm going to end up doing a lot of multiplication by 9. Presumably, I'm going to end up with a lot of carries in this process. That's lots of opportunities for mistakes. I mean, just so we're confident in what the right answer is, I suppose we should do it real quick. 2 times 6 is 12. We have to carry a 1. That's the carrying I was talking about a second ago. 2 times 9 is 18, plus the carry makes 19, presuming we can remember that. We do our placeholder next, and then 9 times 6, 54. We have another carry, 5 now. 9 times 9, 81, plus the 5 makes 86. And then we put it all together. 0 and 2, of course, make 2. 9 and 4 make 13, giving us yet another carry. 1, 1, and 6 gives us 8. We bring down the 8, and we get 8,832. So again, the stacking algorithm there, not super fun. Lots of carrying, lots of opportunities for mistakes. What would this one look like with the distributive property instead? You might think what I'm about to set up is, okay, so let's draw our box, and then let's do 90 plus 6, 90 plus 2, and let's end up with some different products like 540, 180, 80, 100, and 12. But honestly, that's not that much better, right? And one of the things I've been trying to sell you on is the idea that this area model can make things a lot easier on us. Now, there's nothing wrong with this, but again, it doesn't really solve the problem of what do I do with all these carries. I bring down the 2, that's easy enough, but then 4 plus 8 plus 1 still makes 13. 1 plus 1 plus 5 plus 1 still makes the 8, and I guess I don't have to carry in my thousands place. So that's not so bad, right? 8,832. But it's not so great either. So what's going to break the logjam for us here? What's going to be really great? Well, what we're going to do is we're going to take 96 times 92, and we're going to think of them using the area model, but not as 90 plus 6. Instead, I'm going to think of it as 100 minus 4. And 92, you might imagine, is going to be 100 minus 8. And so now some interesting things happen. I see again that 100 times 100 product of 10,000. Obviously, now that the numbers are slightly less than 100, I'm expecting the product to also be somewhat less than 100 times 100 is 10,000, somewhat less than 10,000. And that is what we'll see in just a moment. But because this is a negative 4, when I multiply it by 100, I get a minus 400. And because this is a minus 8, when I multiply it by 100, I get a minus 800. Interestingly enough, though, at least if you're beyond 4th grade math, you also know that the minus 8 times the minus 4 is going to give us back positive 32, which, you may have noticed a second ago, was the last 2 digits of our product. So we line all this up, 10,000 minus an 800 minus a 400, but plus a 32, and what ends up happening? Across these last 2 digits, all I end up having is that product of 32. And then the 100 that's left over here from the 10,000, rather than adding that to the 8 and the 4 and getting a sum, I'm going to subtract the 8 and the 4, and then I'm going to get a difference. 100 minus 8 is 92. 92 minus 4 is 88. 8,832. So let's see this in practice to see if we can shorten some of these steps and end up giving ourselves a nice little heuristic to work with in the future. Let's do several different examples, say 93 times, let's not do 95, let's do 93 times 98, 95 times 96. Again, some numbers that are just slightly less than 100. You can go into the 80s, but let's keep it simple here and stay in the 90s. I'll do a few more of these in the box, and then we're going to try and come up with our trick. 93 is 100 minus 7. 98 is 100 minus 2. We always know we're going to get 10,000 in that box, and this time we're going to take away 700s, take away 200s, but add 14. And so those last 2 digits we should be confident are going to be that product. 2 times 7 is 14. 10,000 take away 700, or if you prefer thinking of it the way we did a second ago, 3 digits only. 100 take away 7 take away 2. 100 minus 7 is 93. Minus 2 is 91. And that's what we end up with here. 9,114. You can trust me on that, or you can go use your calculator. I promise it's going to work. Let's say I don't want to use the box though. What's going on? How can I make this a little simpler? Well, we know where the 7 and the 2 came from. 7 was how far away that was from 100. 2 was how far away that was from 100. So let's think about how far away the numbers are from 100. 99 is 1 away from 100. 94 is 6 away from 100. 1 times 6 is 6, and so we know our product is going to end up ending with a 0, 6. We have to take up 2 digits, 2 places. And then this one, we said, well, if we take away 7 and 2, it's going to end up at 91. But can't we just take away the 2 from the thing where we've already taken away 7? Like 93 already is 100 minus 7. Let's just subtract the 2 more that 98 is away from 100, and that gives us 91. And the same thing is true here. 99 is already 1 away from 100, 1 less than 100. Let's just take away these 6 from the 99. 99 minus 6 is 93. And that is indeed the product, 9,306. Let's do a few more. You can try and beat me on these if you like. This is 6 away. This is 5 away. 5 times 6 is 30. And so that should be my last 2 digits. And then I'm going to say, well, if I take away the 5, that's already 95 from 100. If I take away 4 more, 9,130. Maybe we're getting good enough we don't even have to write this down anymore. 93 is how far away from 100. 7. 91 is how far away from 100. 9 away. What's 7 times 9? 63. That must be our last 2 digits. 7, the 7 that 93 is away from 100, take that away from 91, you get 84. So that's 8,463. Now, of course, you have to be relatively facile with your subtraction. You have to be able to do the subtraction in your head. But presuming you can do the subtraction, hopefully you're getting a sense of how this trick works. 92 is how far away from 100? 8 away from 100. 97 is how far away? 3 away. What's the product of those how far aways? 8 times 3 is 24. Those are my last 2 digits. This one is 92 is 8 away from 100. We've already said that. The 97, if we take away the 8 from the 97, we get 89, so 8,924. Last one, 95 is 5 away from 100. 92 is 8 away from 100. 8 times 5 is 40. Oh, I just lost my light. And of course, take away 5 from 92, you get 87. So there it is, 8,740. I think that's good for one of the math minutes. Again, I want to kind of close out this series on these various distributive tricks. I hope that was helpful for you. I hope you come back and visit again. Make sure to like and subscribe if these are enjoyable for you to watch, and I will see you around.